Good morning, everyone. I am Karthik from the Department of Electronics and Communication Engineering, studying in the fourth semester of BIT College. I have created a presentation on circular linked list in the programming language of C. Today, the agenda will be the definition of circular linked lists, some important operations inside the list, and we'll also look into some of its application and advantages. A circular linked list is basically a type of list where the last node, that is last data, will be pointing obviously to the first node, and there are no null at the end, just like how there is in single linked list. That is the basic differentiation of the circular linked list. Moving on, types of circular lists. There are certainly two types of circular lists, that are the circular singly linked list and the circular doubly linked list. From the representation here, we can see that the singly linked list has a data in the first block, and the next block is obviously the pointer, next pointer that will be pointing to the next node, and obviously here the last node will be pointing back to the first node. Whereas in the circular doubly linked list, the data is present in the middle block, and there is a previous pointer as well as a next pointer. Previous pointer will be pointing to the previous node, previous node's next pointer, and the next pointer will be pointing to the previous node of the second node. Yeah, so looking onto the structure of the node, we can see that the white block here is consists of the data, that is the maybe int data type, char data type, and the other block will be the next pointer, that is the pointer which will be pointing to the next node, and this is the behavior which differentiates it from regular list. Here is a short code snippet which shows the structure of the node, where the data is present and its data type is int obviously, and there is a pointer next, which will be pointing to the next node, and moving on, this will be the function consisting of the argument, which is the value stored inside the node, and this certain line, the malloc function, will be to used to used to allocate memory space to each node inside the memory, and it will be repeated, I mean iterated for each node, and after that the argumented value which will be stored as a data for the new node, and for this new node, the next pointer will obviously be null, because this is the first time we are creating the circular linked list, so it is bound to be null. uh, then the new node is going to be returned. Here there's a function for counting the nodes inside the circular linked list. Starting off, the user defined function count will be used, and the head is the pointer of the first node, and count here is initialized as 0, and we are going to create a temporary variable which will be pointing to the head, and a certain operation will be iterated using the do while operation, where the temp variable will be changed after each iteration to the next node. After each traverser, it will be pointing to the next node, and similarly at that time the count will be also be incremented by 1, and all this operation will continue till the temp is not equal to the head, that is the until we reach back to the first node where we started. And after this, the count variable value will be returned. For inserting any new node into the circular linked list, there are certain steps we need to follow. We first need to point any new node to the head, that is, as you can see in this representation here, the head will be 4 and the new node is 5. The previously this one 4 was pointing back to the first node, that is 2, but after we added the new node, this will the last node will be shifted to 5 and it will be pointing back to 2, and this space will be also be allocated. Uh, for deleting any node inside the circular list, first we choose a node after which node which has to be deleted, that is 3, and we'll select the previous node as temp, and we'll be making its next pointer to point towards the uh, next, I mean the last here, in this case as 4, and skipping 3. And similarly, after we'll be freeing the memory using the free function, uh, and obviously the next is going to point to the last node, that is 4 here. For searching for any key inside a list, we are going to traverse through all nodes recursively. Supposedly, if the key is provided using the input function, and we have a circular list which consists of some nodes. So we are going to traverse through each node, searching for that particular value or key. If the key is present inside the list, then that particular position will be printed, and yeah, it is going to tell that the value or the key is present inside the list. Or else, if the list it's not present in the list, then it's going to return a false value. Looking at some of the examples here for better understanding, these are the circular linked list. Obviously 10 will be pointing back to 14, starting off with 14, and the key value here provided is 14. So obviously we can see that 14 is present in the list here, so output was yes. Similarly, looking at the second example, we can see a list starting from 6 and 8 and pointing back to 6. 8 will be pointing back to 6, and the key value here is 613. So as you can see, there is no 13 in this list. So obviously the output is going to be no. That is a false function, false value. Moving on. There are certain advantages of using the circular linked list. One of which is that we don't need to necessarily provide a last node. Hence, it will basically there are no null references, so the chances of any null pointer exception is far more less. And the second advantage is that we don't need to start from the head to traverse through all nodes in the list. Uh, Henceforth, it is very useful in such certain applications and certain cyclic operations, and it is very good for better resource management. And one of the advantages of circular linked lists I found was the, the usage of the circular linked list in a queue, that queue database structure, and where the first node will be pointing back to the last node. Actually, yeah, the opposite. The node will be last node will be pointing back to the first, and uh, it will help for better resource management. Moving on. Some applications of the circular linked list is that uh, we have seen in multiplayer games, there are turns for each player. So circular lists can be used in turns to give each player a chance, and it's going to repeat obviously, and the last player who played might get a second chance, third chance. Similarly, some other application are it's used in buffering applications where real-time data is used. That is, some of the applications example is a YouTube, and where the data is continuously produced as well as consumed at the same time. So it's an efficient database management. And yeah, one of the major, interesting applications I found for the circular linked list is that it's useful for looping songs or playlists, uh, just like Spotify application. It uses the circular linked list structure, data structure, to loop songs or playlists so that our entertainment is endless. Uh, yeah, so comparing it with other linked lists, uh, comparing it with the single linked list, it's far more efficient and far more efficient to traverse. And comparing with circular, comparing the circular linked list with the doubly linked list, it takes very much less space as compared to the doubly linked list, and so henceforth it's more efficient. And certain pitfalls we need to observe while using the circular linked list, maybe traversing or uh, doing some basic operations inside the list, is that we should watch for any infinite loops. That is, check whenever function is created. Uh, there is no such certain statement which leads to any infinite loop. And secondly, we should carefully manage the head pointer of the list so that in certain examples like insertion or deletion, the right node is deleted and it does not lead to losing any data. Summarizing all what we have discussed here today, uh, why circular lists are more useful, because in certain cases of cyclic data handling, circular list may be more ideal compared to other linked lists or maybe other data structures. And as we have seen earlier, that it's very memory efficient and it's very powerful in terms of like doing the basic operations. And you can see multi-billion dollar businesses have been created on such foundation. And okay, so I'll end the presentation here. uh, if you have any questions, put it down in the comment section and I'll be happy to help you. Thank you.